Alright, today we're going to be talking about constants. So what are constants? What is a constant? Let me clear the screen and let me actually create a file. I'm going to say demo, actually going to say explainer.py, and we're going to just open that up, explainer.py. If you're not familiar with what constants are, many programming languages have this notion of variables versus constants. So C, Java, JavaScript, Swift, even the popular Ethereum smart contract language Solidity, they all have constants. In JavaScript, for example, you will use let versus const to declare a constant. So for example, you will have something like let is begin. They're not going to like this because I have to go and create a new file and say demo.js. Then it's going to be okay because this is not going to work. Let me say let demo. And I can say something like false. Right? This is something that I expect to change, and I expect to modify the value, to alter the value. I'll write some sort of if statement, and if the condition is satisfied, so for example, if I equals this, I don't know what I is right now, but if that's true, then change is begin to be true. So you expect the value to change and to be modified. But then there is also the const, which is something like, let's say, months in year. So months, and you expect that value to be 12. So these are not these are values that you don't actually have to have them in caps, because when you put them in const, this is quite clear that you're never going to modify them. So you don't even need the caps. So you can have something like month and year. And because this is const, if you try to run this in JavaScript and then you try to alter the value, for example, trying to take this value and I don't know, let's say again some if condition, if true, then you have something like this, and you say plus plus, that's gonna just add 1. It's gonna complain, it's gonna yell at you and say you cannot do that, this is a constant, you can change the value, right? So let's go back to Python and talk a little bit about why we should care, or as programmers, why you should be aware of this pattern, right? Why not just use a regular variable for everything, right? So to that, the counter question would be, what if it is indeed a constant? For example, number of months in a year, the example that we just seen earlier, the number of months, or for example, pi. If we import math, let me just show you this example real quickly, and I show you, let me just print math.py. If I try to assign a value to math.py, what should happen? So let me show you what I mean by that, right? If I say math.py equals to 0.05, this doesn't make sense at all, but let's try and do that, and let's say now print math.py, right? The people who argue that there should be a constant for things like that, it's going to tell you, why would you ever have math.py as a variable, right? So for example, if I save this and I go to my Python and I said python explainer.py, hit enter, it's going to give me 0.05. So it first print the value of the original value and then it assigns that to 0.05. This is obviously very wrong, very sinful. So let's just delete all of this and never speak of this code again. Right? But what I'm trying to show you here is that there is a genuine use case for that. In many languages, you would use constants for things that are meant to be constant. So the examples that we see includes pi, includes the months in a year, includes the number of weeks in a year, all kind of things, right? But they could also be used for when you never intend for that value to change. So one practical example from, let's say, the data analytics or data science domains itself is, let's say you read some data off an API and you want to visualize this data. You want to write some code to visualize this data, but you also want to have some guarantees that your code isn't going to modify this value. You read them off the server, because if you modify them, then it wouldn't be accurate anymore, would it? So that is a good use case. That is a compelling use case for actually having that as a constant. If you program this in JavaScript, you would save that as a constant. You wouldn't use the let statement, you use the const. And second is that if you tell the compiler that the value will not change, the compiler can do a whole bunch of optimizations. They can, for example, they can directly inline value and never allocate any space for the constant on the stack. This sounds a little bit technical, but in simple words, it's safe memory, right? So if your compiler did not think that the value of a variable will remain constant, meaning not be modified at all, then it will have to allocate this extra space, and it may have performance implications like avoiding the inlining, the optimizations, of like certain loops, creating objects code that is not as parallelism friendly. There is this quote that says, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." Right? So it's about readability, it's about understanding your code, and generally you should strive to use an explicit constant whenever possible if you're programming in some other kind of languages, and leave variables for things that can actually change. So your code should communicate your intent as clearly as possible, right? And as a bonus, using constant where it should be is also quite defensive. There's this thing called a defensive programming. I don't know if we have time to go into this. I want to keep this video very focused, but you can maybe Google that up. So defensive programming, it helps you avoid risky errors or possibilities of changing values of pi or the likes of that. So there are also some languages with enumerations like Solidity, for example. The enumeration allows you to define a type for a small value of constants. So you can have something like on leave, present, absent, etc. So those are enumeration. So you're saying that the value could only be one of these three. So you're saying x equals to one of these three, right? That's enumeration. And if you use them in conjunction with typing, then it provides even more type safety, right? So let's actually try and run some code example. You've seen the math.py example, but let me just walk you through a few examples of how do you implement constant if you want the benefit of that. Since you don't really have a const keyword, you can't really do something like this in Python. No such a thing. So how would you go about implementing that? All right. So let's talk about the first solution. Now, the first solution is to make use of this frozen attribute from data classes, especially if you're going to be doing OOP anyway. So if you don't know what data classes are, they're wonderful. They're a great feature from Python 3.7. I have a video talking about data classes. I can put it somewhere on the video. You can open them in a new tab and watch them on your own time, but let's stick to this. So if you're using Python 3.7 and above, you can use something like from data classes, and you can say import what? Data class. So if you watch my other video, you know how to create a data class already. So it's kind of very similar to a normal class, right? You have class. Actually, I'm going to show you the const explanation. So I'm going to call this class const, just like that. I'm not going to have anything right now, but I'm just going to go ahead and just say, this is how I'm going to create that. So const. And let's try and print, let's say const .pi. Okay, now we don't have pi, so let's go ahead and create that. So I can say pi. If I want some sort of type, I can have this as a float, and I can give it a value here. Now I don't have the value, so let me go Google that real quick and bring the value in. Okay, so from Google, this is the value. I'm gonna stick to that value. Looks about right to me. So you have the print const, and you can reassign the value if you want. So you can have const.pi, and you can set that to be something, right? Okay, so nothing new that we haven't learned already. But here, with data class, they introduced something called the frozen. I could actually set up something like frozen equals to true, right? So this parameter goes down to one decision. It goes down to one thing. It says, do you want the instance of this? So you don't want an instance of this. So here we're creating an instance of const, right? Do you want an instance of that to be mutable or immutable? It's just that one decision. If you want it to be immutable, what does that mean? Maybe if you never heard of the term before. Immutable means you can't change the attributes in here. So let me actually add a few more later. But you can't change the attributes of this object after it's been initialized. All right. So setting frozen equals to true means the instances, all of these instances, if you create multiple of them, and you want to have like 2, 3, 4, 5, you can have all of this, but all of these are instances of the class, and the instances itself, those cannot modify the attributes of that object. Let me actually go and type, maybe let's create another constant. Let's maybe just to see some examples. You can have degrees to rad, and this will also be a float. And that's also some value. I don't have that value. Let me Google that real quick. Apparently that's the value. Then I could also have rad to degree. Same thing. I'm going to Google that real quick. And this is the value, right? Now, if I try to run this, I want you to pay attention to what's going to happen, right? So let me save all of this. Let me say Python explainer.py, run that. Okay, now I see something. It says data classes dot frozen instance error cannot assign to field pi, and you can try that with something else here. Rad to degree, const.rad to degree. So this is one way to be more defensive in your programming, to be more robust in the kind of code that you write, and to maybe help yourself make less error, and maybe your teammates as well. So this is good. But the caveat is that it comes with Python 3.7. So what if you're using an older version of Python? So one thing you can do is to upgrade. If you're starting a new project from scratch, I recommend you upgrade. It's great. If you want to learn more about the latest version of Python, there is another video that I created talking about the latest features of Python 3.11. I also have a video talking specifically about Python 3.7, data class, and a bunch of other things. So you can check them out on my channel. But if you're using an earlier version of Python 3.7, there should also be some ways to solve this, right? So let's actually remove all of that and see if there are ways we could. So we're not going to have data classes. We're not going to have data class. So we're using Python 3.7. We don't have any of that. So starting from here, very simple, the same thing, class const, no more data classes, no more data class. All right, so we have class const. What we want to do with this const is we want to prevent the user from reassigning attributes if the attribute already exists. So for example, somebody should be trying to do something like const.pi, and we still want to throw an error because that pi cannot be reassigned a new value. All right, so we want to do something like that. How can we do such a thing? Right, let's take a look. When you're trying to set a value like 0.005, this is doing something called a set attribute. So this is called set attribute, and there is a method that governs this behavior within the classes. And if you watch my OOP videos, you've probably seen them already. You probably know what I'm talking about. If you haven't, there is an OOP series that I created. It's in the Python for Banker series. Go and click on that and watch that. But the method that I'm talking about is set attribute. So set attribute, and it goes like this. It says self name. This is a private. This is dunder name. String value any. So we need to import any. So let's go ahead, import any from typing import any. And within that, we just have to check the instance and say whether or not it already has this attribute, whether this object, whether the object already has this attribute, right? So how do we do that? Well, this is something that Python has already provided us with, and it's something like if has attribute. So if has attribute like this, and what do you want to check for? You want to say self and name. Let's actually just keep it. I know it's probably better practice to keep it done this because it's kind of like private, but anyway, let's just keep it like this. Name, all right, just to save out some typing. And what do we want to do here? We want to raise a type error. We want to say, hey, I want to raise an error. You can raise any kind of error, generate error, but I think this is the kind of error that should belong to a type error. So when I say type error, and then you give a custom message, you can say something like already has attribute, and here we're going to put name, right? You are trying to mutate a constant. Finally, if that attribute, if this is false, if there is no such attribute on that thing yet, so let's say if they want to set a new thing, let's set const in year. Oh, we know that's always going to be 12, right? So if they set this, then that will be okay. So if we go ahead and just say something like const, and we try and set this will be okay, this will not be okay, right? So what do I mean by this is this will be okay, right? Because the has attribute will not pass, this will not pass, so it will fail, and so it will do the next thing. So it will not erase, but it will do the next thing. And in the next thing, what do you want to do? You want to do what it's supposed to do anyway, which is to set attribute, right? So you want to say super to set attribute, and you want to pass in both the name and the value. So in this case here, it passed in the name and it passed in the value. So that's the name, that's the value, you set that. All right. So you're saying that if it already has an attribute, of course you want to raise the type error because you don't want to be able to reassign any of this. And let's save that. Let's go ahead and also run that. So clear the screen, and we do Python explain.py has attribute expected 2 arguments, because we of course forgot to pass in the self. So let's save that, run that again. Okay, already has attribute pi. You are trying to mutate a constant. Great, this is exactly what we want. So months in year, no problem. We can go ahead and print that just to confirm. So print const month in year, months in year. Make sure you spell it correctly with a plural. Run that, and it says 12. Great. So this is no problem because this doesn't pass the if check. It says if it has attribute, no, it doesn't have this attribute. So go ahead and do that, do whatever you need to do, which is this. But if it does have an attribute already, which is like this, the pi, then go ahead and raise the type error. I guess you can also do something very similar for the delayed attribute. So you can have something like define delayed attribute, and well, we can keep the name there, right? But we can say something like raise. Of course, you want to do the check, if check. Just save some time. I'm just gonna say raise, and I'm gonna say raise type error. And here you want to pass in a message here saying that you are trying to delete a constant name. Constant name, right? Or you can just pass in the name or constant, and you can just pass in name like this. And so if this dunder, you want to pass dunder. If you want to just perform the check first, if it has attribute, then do that. If not, well, whatever, right? This is the second solution. The first one is to use the frozen, data classes frozen. And the second solution is to just say, well, go and implement our own type error. See whether or not they have attribute, has attribute. If it's true, then raise a type error, delete, raise a type error. You can do that, right? You probably don't need this even, but okay, that's that. And at this point, you're probably wondering, why is it that Python doesn't just provide you this const already? Just implement a const so that we can just do something like const x equals to 5 or like, yeah, whatever, right? Well, why don't we have that? I guess the answer to that is actually a little bit more philosophical and a little bit more nuanced. Let me actually bring you to the guide that talks about this design philosophy of Python. Okay, I'm on this URL, docs.python guide, writing style, the Hitchhiker's Guide to Python. You can just Google that, search that up. I'm gonna search for philosophy here. So one of it is this is the title. It says we are all responsible users. As seen above, Python allows many tricks and some of them are potentially dangerous. A good example is that any client code can override an object's properties and methods. There is no private keyword in Python. This philosophy very different from highly defensive languages like Java, which give a lot of mechanisms to prevent any misuse, expressed by the saying that we are all responsible users. And this is interesting because some days ago when I was scrolling on Twitter, I see this tweet that says, Python always attracted people who have manners, or people who are responsible. I don't know what the exact quote was, but it says, Python always attracted people who have manners. If one gentleman announces a constant at the top level, like pi, capital, that's kind of a convention that should be treated as a constant. And it says capital Pi equals to 3.14, 15926 or 296. Another gentleman does not need an enforcing mechanism to behave nicely. So it's saying that we are all responsible users. When you see that, you should be responsible. You should have the good sense to know not to mutate the value when it's already capitalized. So it doesn't try to enforce that. It doesn't give you this mechanism to prevent the misuse, but it just assumes that you as the developer, you are responsible and you are not gonna try and make life difficult for another programmer. All right. So I find that deeply amusing. Let's close down the browser and let's go back to our terminal. I want to talk about the final thing about constants, about how to enforce a constant. And in fact, this video will not be complete without actually talking about this. We cannot talk about the subject of constants in Python without mentioning PEP 591. So this is new in version 3.8 and it introduces this thing called the typing.final. So let me delete all of that now. Don't need all of that now. But if you're using Python 3.8, then you can go ahead and try this. So it says from typing import final. And let's go ahead and create a class as well. So we can create a class. We can call this a class. Let me show you what the final does first, and then explain how you can use that. All right. So class. Let's create a class, a basic class, a base class. We define init. So this is the initializer. Self. It should return what? It should return none. And what else? Self. Let's make it simple. Let's say x equals to 0, -1, because I want to use the 0 later. And I want to have a derived class, and derived class is going to just inherit from base, and once it inherits from base, you want to override this init method. So we want to say define init, and again same thing, self, same thing. It's gonna not return anything, just gonna set some values, nothing get returned. So this is saying that what is the type of the return value? Nothing, right? I'm gonna have super. So this is basically gonna call the base class, right? And I'm gonna call the init here. This needs to be called first. So x would now be set to -1. So if I create dir equals to derive, and I say dir equals to x, I want that to be -1. Even though I did not declare a variable in here, it inherits from this. All right, so it should be this. You should assert that this should be true. We're not gonna do that. We're not gonna do the assertion. I'm just gonna show you what it looks like first, but don't worry about that. If you want to, you could just try and add another attribute and call it y, for example. This is okay. This is a very basic pattern, right? You create a base class, you create a derived class, it inherits from base, and then it sets a value. And there is no problem. You can run this and there's no problem. But this is interesting because we can now use final and we can put this final in here. So let me copy that. We can use this as a decorator pattern. And now all of a sudden, we're getting an issue here. It says base class base is marked final and cannot be subclass. Okay, that's interesting. It's saying that, okay, if you create this as final, this cannot be subclass, and you then therefore cannot reassign the value to be something else. So if the x is now -1, you cannot reassign x from the initialization anymore. All right, that's good. And you can use that in conjunction with what you just learned in the two other techniques that I showed you. So you can also make this something that you check for using a type and then raise a type error, you know, so assert something type error. You can you can combine the two techniques together. But here it just gives you an error. It says base class marked is base class base is marked final, cannot be subclass. All right, cool. What happened if we move this final decorator down? What happened if we move this to an internal function? For example, we say define pi self, and this is not going to be none anymore. This is going to be a float. So we're going to just return, And now I have the pi, so I can maybe go ahead and say from math import pi, or if you're going to use a lot of the function, let's just import math directly, and then from here you can just return math.py. What happened if we move this final down? Tap it in like this. Well, now the error goes away because this is inheriting from base, and base no longer has that final, so this is fine. You can now inherit that, no problem, but you cannot now overwrite this pi. So if I try something fancy like define pi self again, and I'm gonna return a float, so I'm gonna have float. If I try and return something negative, I don't know, some crazy values. All right, some crazy values. Then what do we get now? Method pi cannot overwrite final method defined in class base. So that's the final. So that's pretty cool, right? And as a bonus, from typing import final, there is also, this is a decorator, but what if you don't want a decorator? What if you want to type? So you can also have this capital final F, capital F final, right? This is the capital F final. This is a type qualifier to indicate that this variable, for example, this variable, it should not be reassigned or redefined or overridden. So if you set this final to any attribute or variables, then the type checker would check that, hey, this cannot be reassigned, it cannot be overridden, it cannot be redefined, right? An example of that, let's go ahead and say pi. Let's make it final. Notice that if we put a lowercase, that's the decorator, so that's the wrong one. We actually want this. This is the type of that, right? And we set a value. I don't know the actual value. I know maybe 141592 something. I don't know the rest of that. And now your type checker is going to check that this is not redefined. All right. And same thing, you don't actually even have to use them with a class. You can actually just hide all the classes, just remove, forget about all of them. And you can just do something like this. You can say number of months in year. Right. This is a lot of, I now regret of picking such a long name, but it is what it is. We set something like 12 months in a year. Cool. And if we go ahead and try to reassign a new value, assign a new value to this, and we set this to be 15, right? So decided 15. See, there is no problem here, and we can print number of months in a year. Just gonna copy off this, and if you save that, so it's still complaining about this pi thingy. Let's just hide that out for now. So problems is gone. If you run that, you would expect 15. There's no problem, right? Run that. Okay, you get 15. Cool. But if you try and make this a final, now it's going to complain. It's going to say what? Num of months in year is declared as final and cannot be reassigned. So this is as close to, you can delete off this already now. You don't even need all of this anymore. Just delete off that. Just do this. This is so simple. This is as close to a const as it gets, I think, in Python. I don't think we ever get something like const. Maybe we will, I don't know. But as it stands right now, this is as close as it can get. Really just one line of just adding this final equals to 12. And now it's going to complain. The type checker is going to complain, right? So those are the 3 ways you can work with constants in Python. Let me summarize. So constants provide some level of guarantee that your code can't change the underlying value. This is not of much importance for a small project. You're doing some sort of pet project, hobby project, no problem. Writing something in a notebook, Jupyter notebook, no problem. But it matters on a larger project with multiple components written by multiple people, authors or collaborators. So you want to have some sort of guarantee that, hey, do some sort of type checking and stuff, right? And in programming languages that support it, constants also provide a strong hint to the compiler for optimization opportunities. So the compiler will know that the value cannot change, and therefore it doesn't need to load the value from memory and can optimize the code to work for only the exact value of the constants. And these are things that matter in programming languages that support that. So probably not a big deal in Python. But while the optimization argument isn't strong, there is the defensive pattern may still be very helpful when you're trying to build out something more complex, right? When you use that in conjunction with type hinting and other similarly defensive practices, it's good. So if you'd like to read more about this topic, Google search on defensive programming and read up about that. That's all I have time for today. Share the video to your other Python programmer friends. Catch you another time.